students. Today we are going to discuss about public key algorithm called RSA algorithm. So RSA stands for Ravished Shamir Edelman. So the starting letter of these three scientists they called RSA. So RSA algorithm. This is one of the most important public key algorithm which is used in real-time applications. So this is one of the most important algorithm which is used for like login pages. They are using RSA algorithm. Now we'll see how this RSA algorithm will work, how this algorithm will provide security to the data. So Ravisht Shamir Adalman's team has since the time began securing as the most widely accepted and implemented general purpose approach to public key encryption. And this scheme is a block cipher in which plain text and ciphertext are integers between 0 and n minus 1 for some n data. And typical size of n is 1024 bits. So minimum in general, the key size for RSA algorithm is 1024 bits minimum. So if you take DE's algorithm, the key size is 56 bits. Similarly, for AES algorithm, we have three different types of key sizes 128 bits, 192 bits, 256 bits. But for RSA algorithm, the minimum size is 1024 bits. Now we will see how this algorithm will work. So in general, RSA makes use of expression with exponential set. So we will take exponential equations, we will substitute the values, and plain text is encrypted in blocks, with each block having a binary value less than some number n. So we will take plain text in the blocks, and that blocks will be used as binary values. Through that, we will convert from plain text to ciphertext and cipher to plain text. And if you see, like general symmetric algorithms, so symmetric algorithms will take plain text and it performs a different type of rounds, and it will convert the plain text into ciphertext. But this RSA algorithm will use very minimum expressions. And if you see here, it uses only two simple expressions for converting plain text to ciphertext and cipher to plain text. These are the equations it uses. So for converting plain text to ciphertext, C equal to m power e mod n. And for converting plain ciphertext to plain text, it uses equation m equal to c power d mod n. So that is equal to C stands for like a plain text. So C you can substitute now m power ed mod n. These are the two simple equations that it uses. Through these equations, it converts from plain text to ciphertext and ciphertext to plain text. For converting, just we need to know what is the m value, what is the small e value, and what is the n value. So if we know these three values, we can convert from plain text to ciphertext. Similarly, if we know c value and the small d value and n value, we can convert from ciphertext to plain text. So, but before converting these things, we need to know what is n value, what is small e value, what is small d value. Now we'll see how this algorithm will work. Both sender and receiver must know the value of n. Yes, we should know as a sender and receiver, we know what is n value. Through the n value, we can easily convert from plain text to ciphertext. The sender knows the value of e, and only the receiver knows the value of d. So here we can call it as E as public key, D as private key. So sender knows the value of E and the receiver knows the value of D. So that this is a public key encryption algorithm with a public key PU. PU stands for public key E comma N. E so public key knows E comma N. That comes under public key value, and the private key is nothing but PR stands for private key that equal to D comma N. So D value only receiver knows, so we can call it as private key. So the combination of D and N called as private key. So the algorithm to be satisfactory for public encryption, the following requirement must be met. So it is possible to find the values of E, D, and N such that m power ad mod n equal to m for all m less than n. So as I said earlier, we should know small d value, and n value. So if we know everything, then that will create capital M. What is capital M? Capital M previously we have discussed. Capital M is nothing but we have plain text. Okay. Next point is it is relevantly easy to calculate M power E mod n and C power D mod n for all values of capital M less than n. Yes. It is feasible to determine D given E and E. So if we want to calculate the private key value, we should know what is public key value and n value. So once we satisfy all these conditions, now we are going to see the 4 steps in this RSA algorithm. So these are the important 4 steps. Once we execute these 4 steps, then easily we can calculate C value and M values. So first thing is for RSA algorithm, always we will take two prime numbers. So P comma Q, two prime numbers we need to choose. So these two prime numbers will plays a major role. So if you remember the symmetric algorithms, there we are using different key sizes, different plain text block sizes like 64 bits, 128 bits. We were doing so much things and so many rounds we are executing. But in this model, nothing is there. Simply we need to select two prime numbers, P comma Q dot solve. Next, we need to calculate n value. So n equal to P into Q. Then once we calculate n value, then we need to calculate e value. So for calculating e value, formula is GCD of phi of n comma e equal to 1. So here for phi of n value calculation, the formula is p minus 1 into q minus 1. This already we have studied in number theory. So we know how to calculate phi of n. Phi of n equal to p minus 1 into q minus 1. So we will get that value. GCD of that value comma e equal to 1. So randomly we need to substitute the values of e so that which value will satisfy that condition GCD of phi of n comma e equal to 1, then we can select that value. So there is no rule that we need to select first value. So randomly we will substitute. So we will get multiple options for that condition. So based upon that, we can. So that is the beauty of this RSA algorithm. So the value of E is not fixed here. So if I will substitute equal to 1, equal to 2, equal to 3, so equal to 1 also satisfy that condition. Sometimes equal to 5 also satisfy that condition. So based upon the security level, I can select E equal to 5. But E equal to 1 also will satisfy that. So if any attacker attacks, they don't know what type of E value you have taken for our problem. So that is the secret in this algorithm so that it makes more powerful. So once we calculate the E value, so then we need to calculate the D value. So for D value, D congruent e power minus 1 mod phi of n. So similarly here also, for once we calculate E value, then easily we can calculate D value. So once we executed all 4 steps, after completing this, we know what is P value, what is Q value, what is N value, what is phi of n value, what is E value, what is D value. So we will get all these values. So then we can substitute for public key D comma N, private key, sorry, public key D comma N, private key D comma N. So then you can take any plain text value so that we can substitute here. So C equal to M power E mod n. Similarly for ciphertext plain text M equal to C power D mod. So this is how we are converting plain text to ciphertext using public algorithms like RSA algorithm. And this is one simple example. So here we have taken P equal to something, Q equal to 11. So then N equal to PQ. So we'll get 187. Next we need to calculate phi of n value. Phi of n equal to P minus 1 into Q minus 1. So we got 160. So once we calculate N and phi of n, then we need to get the value of E. So for E, GCD of phi of n, comma E equal to 1. So GCD of 160 comma next I need substitute value for E. So I can substitute 1, 2, 3, 4, 5. So like that I can substitute so that I can select E equal to 7. So then once I know the E value, then I need to calculate the D value. So DE equal to 1 mod 60. So here also randomly I can substitute the d values which satisfy that condition. So I got d equal to 23. So then I can convert c power m power t mod n. So I can substitute any value so that I can convert it. So for this you can see here. This is a simple equation which we can understand. So you can see here p equal p comma q will be there, n equal to p into q, phi of n equal to p minus 1 to q minus 1. So E GCD of phi of n comma E, D ED equal to 1 mod phi of n, then public key, private key. This is the plain text, ciphertext. C equal to m power ED mod n, and for plain text, m equal to C power. So this is how we're converting plain text to ciphertext to plain text. Thank you.